Hello and welcome to topic 2C. It's really topic 1 and 2C, where just to wrap up the section, the topic, I want to reference the book by Huck, Reading Statistics, and where they present excerpts from actual written research papers, articles, things like that, to illustrate how practically relevant this topic is. That these are actually things that are done. If we talk about the mean, that is things that those are things that people use all the time. We are not making stuff up. This is actually used. And then in the process, we can also sort of examine sometimes the presentation of some of these little excerpts. Is it presented well? The clarity, are they explaining things with sufficient amount of detail so that we can learn from it, avoid mistakes here and there, and just be more informed? So it's really just a little afterthought for our purposes, but still something important that I want to be aware of. All right, so I just have a few of the excerpts from that book. Of course, they go in way more detail and words and explain things. It's a very good book. I highly recommend. So first up here, we see that a simple frequency table is quite common. In this case, we're looking at the number of days per week that people engaged in vigorous intensity physical activity. They show the N here, see a standard N symbol for the number of scores, and more information here, number of days. Of course, that is the only range possible, 0 to 7, backwards in this case. You have to ask yourself why, because they maybe want to draw attention to the higher scores, and then the number of students, and these should of course add up to 100. So simple frequency distribution. In this case, they give the percentage not as a separate column, but in brackets. You have the flexibility to do things like that, and it's still quite clear what it means. Grouped frequency distributions are quite common as well. When my range spans a lot of uh, different values, especially when I'm trying to write a paper or when I'm trying to read it, I don't want to see a table that's too big, right? I want to have it sort of summarized. So picking age groups in this case makes total sense. It should ideally be the same size groups. And in this case, I have two tables sort of in one, men and women. No percentages given. Now, this is just an excerpt. They might reference the table and explain more and give some percentages there. The percentages are always nice because that makes things relative and comparable. Histogram. In this case, the histogram bars don't touch. The authors had the option, I guess, to present it in a way that looks the nicest. There used to be a time when the histogram had to all the bars always had to touch, but I think things are a little bit more flexible because it doesn't uh, change what the information really is, right? And I see here a very nice, sort of very symmetrical uh, profile, my distribution. What's very nice and helpful is that they started the vertical axis at 0. Sometimes people try and cut off the bottom to make the peaks exaggerated and do things like that to give an inaccurate impression of what your data is. Next up, truck outside apparently. Hopefully it's not too noisy. I'll speak up. I have a distribution here that shows a very nice negative skew. That's the only point here, that the different skewness profiles can definitely occur. Not everything is going to be centered. Sometimes the graphs aren't necessarily shown, but just referenced. And I have to understand what those terms mean. For example, here, preliminary analyses revealed that the data were normally distributed. Now, in fairness, we don't really know what that means just yet. We're building up to that, but it's a very important term. But we'll get there, don't worry. Middle one here, the sample's actual range of scores on whatever scale covered the entire theoretical range of the scale, but the distribution was extremely negatively skewed. So they can describe in words what the profile is without necessarily showing every graph, and in that way save a little bit more time when it's not necessary to show it. Last one here, the histograms of the score distributions for both that and coping religion scales indicated slight tendencies toward bimodal distribution, meaning there are two separate peaks. The mode is, of course, the scores that occur most often. Reporting multiple measures can happen. It's always a space issue, right? You want to be as concise, but yet convey all the relevant information. So it's a tricky balancing act. It's the opinion of the authors that patients are often needlessly kept in hospital as inpatients. Mean stay of the cohort patients in their study was 12.9. Brackets, they show the median and the mode, because that in those three give you information, right? They don't have to elaborate more necessarily. With the mean stay of patients who spent a potentially avoidable night, 13.7 days, median given, mode given. Useful to have more information. I can then see, oh, well, mode, that means skewness, and it's all in there. Another excerpt here, the median age of all participants was 66 years, and then in brackets they give an interquartile range, and the whole range, attention to, maybe this is part of a larger discussion. So the point here is more information is better. You don't want to be overwhelmed with information, but you don't want to give just the bare minimum. It doesn't paint the picture fully. You see a box plot, something we just did in we just saw in the previous video. Now there's some variety in box plots. Uh, in this case, the whiskers, the line at the end, could mean the whole range from minimum. Sometimes it's the 90th percentile to the 10th percentile, sometimes the fifth one. There is some variety, and it's always good for them to explain exactly which one they're using. So I don't want to read absolutely everything here. They give the number of people, number of scores, and then they explain what their box plots mean. Central box spans from the lower to the upper quartile. That is pretty standard, but it's good to say. Middle line represents the median, and the plus sign represents the mean, so they have a little bit more to it to show where the mean doesn't sit quite on the median. The whiskers, these little lines at the end, extend from the 10th percentile to the 90th percentile. So now you know. They're not trying to hide it to make the lines, the whiskers, look shorter or longer or anything by not explaining. They are upfront and explain exactly what these mean. Again, I apologize if you hear the truck at the background in the background. Hopefully he's leaving. He doesn't seem to be leaving. He's just going back and forth. Mess up my video. But hopefully you don't hear too much of it. I will talk louder. Then we have a table here that represents all the standard stuff, the mean, standard deviation, see common ways to reference it, the range, and so on. Using variance, to measure dispersion or variability or spread. To explore possible gender differences in reading performance, we analyzed data from two samples. Although the difference between the average reading scores of males and females in these two samples was very small, the variance of reading performance was significantly greater for males in both groups. So you can reference the variance in this informal way, just as you can the standard deviation. It's just for calculation purposes, the variance isn't quite as clear because of the units being squared. But when we talk about measuring spread, dispersion, variability, you can reference the variance just as the standard deviation. MSFC scores were determined for all participants. Now this one refers to a standard z-score, which I don't want to get into, but we are going to discuss that, and it's going to be a main focus of the middle portion of the course. But they reference here again baseline, mean, standard deviation values, and so on. So don't worry if you don't know what a z-score is. We'll get to it very, very soon. Same here. In the excerpts, we're going to see things that we don't necessarily understand at that time. We are going to explain these things like a t-score. Definitely, don't worry about that. The important thing here is that we had a score. They're talking about 32 points above the mean. You understand the mean of 50, and they are talking about standard deviations above the mean. All these things are going to make more sense in a few topics time. Don't worry. Dealing with outliers, very important. You always have to think, uh, did the researcher consider outliers when they don't say anything? Maybe they forgot, maybe they didn't care, or maybe they're trying to hide something. You have to read with a little bit of suspicion. But when they come out and say there was only one outlier that deviated by more than 3 standard deviations from the variable mean, now you know, okay, they measured their cutoffs by counting standard deviation steps. We're going to clarify that soon. They're not trying to hide anything. That is the point. Other excerpt here, outlier individual data points, were excluded. They tell you when it was excluded. If the values exceeded the inner fences of the interquartile range, 1.5 that we saw in the SPSS, right? By 1.5 times the interquartile range, above or below the box, which is the first quartile, 25th percentile, and the third quartile, which is 75 percentile. So this is exactly what SPSS did as well. Say because there is some variation on when a score is considered an outlier. It's good to see good descriptive summaries where all the information is there in a wordy summary, not necessarily a table. It's up to the author, but you always want that clarity. It's good to see how does that sound, how does that read. Social communication questionnaire for autistic spectrum disorder was previously validated in clinical populations. Yet to date, there has not been a report on the use of the 40-item scale questionnaire in a sample representing the general population. So they're saying, of course, it's part of a larger document, but they're sort of summarizing why are we doing this? Oh, because it's not, uh, there hasn't been a report using the 40-item questionnaire before. Okay. Then they get to the specifics. A total of 153 questionnaires completed by parents were included in the final analysis. The data had a range and a mode of 1 and a mean and a standard deviation, all the important things. Distribution was not normal. We'll clarify what that means soon. skew to the right, and they give the numbers. There were 4 outliers. Maybe in another area they did say how they were determining that. I'm just scanning over this. And then they removed the outliers to look at the corrected mean, those removed. And then we can see those, that mean standard deviation is much more representative of the whole group because those outliers pull these measures unfairly, perhaps. And the skewness and the kurtosis way less. Wow. Wow. Those outliers had a huge effect. All right. The point here is, again, clarity. Clarity. Now, this is a summary. So this detail was probably uh, referenced earlier in the paper. And in the summary, they want to be concise and just sort of repeat those key things. So with this, again, just a short little discussion so that we can start being aware of when we write something. Maybe you're the one doing the research. You want to be clear, yet concise. Tricky balance. Want the reader to go like, how did you pick an outlier? Did you even think of outliers? There's no mention of outliers. Did you even consider that? Things like that. And when you read research, maybe you have an important decision that you have to base on this research. They can't just hide information because then you don't know, was it considered? They're just not explaining it, or did they actually not consider this at all? And how, and if that's the case, how does that affect the results? Clarity is very important. Clarity in presentation that effectively conveys the information that important or very expensive decisions might be based on. So it's very important to be aware of these things, regardless of which side you're on. So that's the point of the C portion of the topics, just to raise that awareness and start thinking. When I read something, I have to think a little bit. How's the presentation? Is something missing? Why is it missing? Things like that. All right, that concludes topic 2. Until next time.